Under the cis-trans stereoisomer category, we're going to be investigating two different structures. This video is going to be focusing on our cycloalkanes. In the cycloalkanes, because of the cyclic nature, the atoms cannot freely rotate around each other, which means that they are locked in place. Because they are fixed or static, any substituents that are bonded to the cycloalkane can then have a cis or trans designation. When using the model for a cycloalkane, it is very easy to see where the locked carbons are at and then the position of the bonded substituents, whether or not they are on the same side or opposite sides of that cyclic structure. However, you need to be able to look at a drawing and still be able to determine if the structure has cis or trans stereoisomerism. In these top images, these rings are called conformational style drawings, which highlights the three-dimensional view of the structure. The darkened bonds shows us or tells us that that ring is coming out towards the observer. When this style of drawing occurs, we can then assume the placement of these substituents based off the direction of the bond. If that bond is pointing up, we're going to assume that the bond is above the ring, and if the bond is going down, we're going to assume that the bond is below the ring. Drawing conformational structures are not easy, and so a lot of times we will draw the ring in the two-dimensional space on our paper. But that does not then alert us to the directions of the bonded substituents or groups. We then will use our dashes and wedges to represent the three-dimensional nature of these bonds. A wedge, which is a darkened triangle, tells us that the group is going towards the observer. The dash tells us that that bond is going away from the observer. When you have one of each, that is going to represent that trans formation, whereas when we have two of the same, that is going to show us the cis formation. So in our cyclic structure, we have a substituent that is going below the ring and a substituent that is going above the ring. Therefore, they are across from each other, as shown both in the model and in the static drawings. This is going to give us trans, and then we need to number. So since the bonds are directly next to each other, they're going to get that 1, 2. They are both methyl groups, so dimethyl, cyclo, pentane. So in that other structure, so we have that carbon ring, and we can see that our bonded substituents are on the same side, whether it's above or below, doesn't matter, but it's on the same side of that ring. So that is that cis. Again, numbering where those substituents are at, so carbons 1, 2, dimethyl, cyclo, pentane.